This worksheet is from section 1.4, some additional examples. In number 1, we want to solve for the base b of 5 times b to the 7th plus 42 equals 212. So our first step is going to be to subtract 42. So what's left is 5b to the 7th equals 170. And now we're going to divide by 5. Since it was 5 times b to the 7th, divide by 5. And we're left with b raised to the 7th equals 34. Now we want to solve for b, so we have to get rid of that 7th power. So we're going to take the 7th root of both sides. And the 7th root of b to the 7th, that is the 7th root of b to the 7th, is just going to equal b. And we want to take the 7th root of 34. Now, many calculators won't have the 7th root, so another way that we could do it, if it was b to the 7th equals 34, we could raise both sides to the 1/7. That's the same thing as taking the 7th root. So your 7's will cancel and we're left with b to the 1st equals the 7th root of 34, or 34 raised to the 1/7. Now, when you do this on your calculator, you have 34. Depending on the operating system you have, 34 raised, you have to make sure that this exponent, this 1 divided by 7, is in parentheses. So 1 divided by 7, close your parentheses, because that's how you have to tell it to do that division before that raised to. So this is 34 raised to the 1/7. And we get 1.6549. Now, other calculators have, a different operating system. If we go 34, as soon as we hit that raised, you can see it's almost like that little box. Now it's going to be an exponent until I tell it it's not. So we can go 1 divided by, we don't need parentheses, 1 divided by 7, and you can see how it's raised to. That's dealing with that exponent. And again, we get that 1.6549. So that's that 1.6549. So just watch your rounding. It's good to take it out to at least 4 decimal places, unless it tells you to round to the nearest tenth, nearest hundredth, nearest thousandth. Now what we could do is we could check this. So since that number's stored in there, we could go 5 second negative to get that answer, raised to the 7th plus 42. Oh, see, I have to delete because I'm still as an exponent. So I'm going to go back to that plus, delete, delete, and we have to arrow over to say this is not an exponent. So now plus 42, and we should get 212. So it checked, so you should feel pretty good about your answer. Now, if we use the decimal part of it, so if I go 5 times 1.6549 raised to the 7th, now this one I have to arrow over, plus 42, when I hit enter, notice we don't get 212 exact, 211.97. We're in the ballpark. It's pretty close. The difference is that answer is rounded when you put it in. Okay. So here's our base, our b. Now we want to find the equation y equals ab to the x of an exponential curve that contains the points 0, 12 and 5, 48. So if we start by plugging in our 0, 12, so we're going to pick that point first. So our point 0, 12. So this is x is 0, y is 12. So 12 equals ab to the 0, which is 12 equals a times 1, because anything to the 0 exponent is 1. So that's our 1 right there. So we know that a equals 12. And we know this because this is our y-intercept. So our starting value, our a value, is going to be that 12. And this is the case always with the y-intercept, if it's given. But if we take a quick look down here at 13, 13, 4, and 7, 84, we're not given that y-intercept. So in number 3, we don't know what a is. But in number 2, we know a equals 12 because we were given that y-intercept. So now we have to use the other point, 548. And again, I'm starting over again. This is my x, this is my y. So 48 equals, now I know my a now, it's 12. I don't know b, but we get 5 as our exponent. So 12 times whatever b is to the 5th should equal 48. So now I'm going to solve for b. Notice this one equation, one unknown. I want to solve this for b. So we're going to divide by 12. And we get 4 equals b to the 5th. And now, like number 1, I want to solve that for b. So I need to get rid of that 5th power. So I'm going to take the 5th root of both sides, or go 4 to the 1/5 equals b to the 5th to the 1/5. And this will leave me with b to the 1st equals, now 4 raised to the 1/5. So we have to go back to our calculator with that one. And again, I'm going to use this calculator this time. So it's 4 raised. Now I have to use parentheses on this one. 1 divided by 5, close my parentheses, and we get that b equals 1.3195. So you have to really make sure you know which calculator commands you need to evaluate it correctly. So now here's my b, I have my a, I'm looking for find the equation, so I have to put them together now. Y equals 12, that's my a, times 1.3195 to the x. Now I can check that, so I'll go back to this one. So 12 parenthesis 1.3195, close my parenthesis, raised. So this is that different operating system. I want to raise, and what I could do is I can check either one of these points. If I put 0 in, I should get 12. Anything to the 0 exponent is 1 times 12 is 12. So I'm going to check this other point. When I put 5 in for my power, so when x is 5, when I evaluate this, I should get something pretty close to 48. Now I say pretty close because remember, this is rounded. So when we hit enter, 47.99856, it's pretty close to 48. So if it was way off, you know you did something wrong someplace. Now number 3 is a little harder than number 2 because again, I'm given 2 points. However, I'm not given the y-intercept this time. So if we go, so point, I'm going to start with 7 and 84. So this is my x1, this is my y1 on my first point. So y is 84 when a, I don't know, b, I don't know, but I know my x is 7. So if I knew a, I knew b raised to the 7th, I should get 84. But notice there's 2 unknowns in this equation. So now I'm going to use my point 13.4. So again, so this is my second point. I'm just going to label those. So this is going to be that y is 4 equals, I don't know a, I don't know b, but I know my x, my power, is 13. But again, I have an equation with 2 unknowns. So this one's a lot harder to solve. I don't have A right off, and I can't use that to find B. But what I can do is that second one and go 4 equals AB to the 13th. And I'm going to divide by 84. So here's my 84. And if whatever I divide one side by, I have to divide the other side by. Now I put this 84 lighter because I'm actually going to erase it. This 84, since 84 equals AB to the 7th, instead of writing 84 here, I can write that AB to the 7th because it's equivalent to 84. And you can see now that I can reduce this. This is going to be 4 over 84, which equals, and now I can reduce this to b to the 13th minus 7. When you're dividing same base, subtract those exponents. So we have 4 over 84 equals b to the 6th. So now to solve for b, I'm going to take the 6th root. So b equals, now because this is even, this is really plus or minus 4 over 84 to the 1/6. Now, since it's even here, if you positive to the 6 is positive, and the negative to the 6 is going to be positive. An even number of negatives is positive. However, since this is an exponential curve, since you're looking for an exponential curve, we know our base has to be greater than 0, has to be positive, and b cannot equal 1 by our definition of an exponential curve. So even though there are two answers here, that minus 1 I'm ignoring because of the exponential curve. So b equals, now if we plug this in, it's going to be, so I'll just clear that out. Now I'm going to need parentheses, 4 divided by 84, all of that raised to the 1 divided by 6, that 1/6, and we get 0.602. So this is going to be 0.602. So now I know my b. So now I have to find a. So I'm going to use either one of these points. So we could use this one since I know b, or we could use this one since I know b. So I guess I'll start with the 84. 84 equals, I don't know a, but I do know b now. It's 0.602, and I know my x is going to be that 7 to the 7th. So notice in this equation I have only one unknown. So if we divide by 0.602 to the 7th, whatever we do to one side, we have to do to the other. 0.602 to the 7th, those are going to cancel, and we're left with a equals, so it's 84 divided by, parentheses, 0.602 raised to the 7. And we get 2931, so 2,931.59. Now again, for your rounding, just be careful. You know, if it says to round to a certain tenth, hundredth, thousandth, then make sure you round accordingly. But also remember, we were looking for find the equation, so we have to put these two together. So this is y equals 2,931.59 times 0.602 raised to the x. Here's the exponential curve. Now something else I could ask you, notice how this base is less than 1, so this is an exponential decay. Notice how it's going from 84 down to 4, so that curve is going to look like this. It's going to be that exponential decay curve. And if we wanted to know what the rate that it was decaying at, we would take that base and subtract it from 1. So 1 minus 0.602 equals 0.398. So it's roughly a 39.8% decay rate per whatever the time units would be.